Welcome. In this video I will do more examples on limits. So I have those two examples that I will do. So you can pause this video and do it by yourself. Let's get started with our number one, which is a limit of square root of 9 plus x minus 3 divided by x as x approaches 1. So what is the limit of this as x approaches 1? So if you have any root on your limit and it is in this form, the root plus any num, the root plus any num, the root or negative any num, there is something which is called a conjugate, which you can apply, like the conjugate of root a plus b is root a minus b, vice versa. The conjugate of root a minus b is the conjugate of root a plus b. So here we can apply this concept of conjugate. How? Because here this limit is being multiplied by 1. So we can manipulate this one in form of this conjugate. How? So let's write our limit as x approaches 0 of square root 9 plus x minus 3 divided by x. So I have this. So I can then manipulate this one here by saying multiply. Then I can come here, write the conjugate of 9x plus 9 plus x inside my square root, and then the conjugate of this, which means I will have the positive sign here. As you can see here, the conjugate of when we have a negative sign in between, the conjugate will have a positive sign. So the conjugate for this, if we have a positive sign and then divide again with this conjugate in order to be 1. So I'll have something like this, and this thing is equal to with this one here. So now I can come into my limit and say limit as x approaches 0. Then I can do a distribution here for it. I can say this square root of 9 plus x times the square root 9 plus x, and I will left something that inside my square root, which will be 9 plus x. Then I can say this square root times 3. I will get 3 root 9 plus x. And if I'm coming with this side here and say minus 3 times 9 root, like those two here, if I'm saying this times this one and 3 times this one, they will cancel out, so I will end up with 0. So which means, and then I can say negative 3 times positive 3, I will have negative 9, and then I will divide with my x, and I will leave my lower part as it is here. Then I can see what will happen here. So if I will look clear, this 9 and this 9 will cancel, and I will left with x, and this x will cancel with this x here. So which means I will left with only 1 over root 9 plus x plus 3. So now we can perform our direct substitution here, because we will be no longer having something which will be look like the one which we faced before. So now we can perform our direct substitution. So let me make a space here, and this one. And this one. So I can come with my direct substitution, then saying that a limit as x approaches 0 of this left part here is indeed equal to, and then I can directly substitute my x. I will have 1 over square root 9 plus 0 plus 3 here, and then I can say, I can know now the square root of 9 is 3, so I'll have 1 over 3 plus 3, and this will be 1 over 6. This will be your answer for this equation here. This is how you simplify your this is how we evaluate a limit with a radical. You just have to do what is called a rationalization. That part of conjugate is also called a rationalization. So let's go for the next example. So in our next example, we have this complicated fraction. So if we have a fraction that is being again divided by another fraction, so what we have to do, we have to take the upper function and take their numerators and their denominators and multiply them, so and then times with them outside. So what we will do here, and just use a line here and take this function here. Let's say this is our f at x, so I will just take that part. So I will have 3, I'll say this 3 times this x, I will have 3x, and then I can then multiply my x over 3 minus 9 over x, then divide all with x minus 3 here. So what I will get here, I will say, as you can see here, this 3 will cancel out. It's just 3 when I'm multiplying this term with this one, and I will end up having no, this is was x squared, and this is what x squared. So I'll end up having x cube here, and then if you see this x and this x will cancel out, and I will have minus 3 times 9 is 27 divided by x minus 3. So which means my limit will be the limit as x approaches 3 of x cube minus 27 divided by x minus 3. So still there's nothing that I can do here, because if I'm doing direct substitution, I will end up with 0 divided by 0, which will be undefined. So what I have to do in order to avoid that, I have to factorize my numerator. So I have, so if you want to factorize something like a cube minus b cube, what you do, you just open a two parentheses, one and one large, then you have your a minus b here, and then you have your a squared, then your b squared here, then you multiply those two that are inside this bracket, then you multiply and then change the sign. So I'll say a times b, then change the sign, it will be positive a b, then you add that one here. So we'll also apply the same thing here, and then we'll have a limit as x approaches 3, then I have my open parentheses here, those two, and then I divide with my x minus 3, then I have x minus, so what is the cube root of 27? So, and it is 3, so which means I will have 3 here, then I can have x squared, so that if I'm saying x times x squared, I get x cubed. What is the value that I can say? Negative 3 times that value, and then get what? So if you know 27 is equal to 3 cubed, so if you know I'm already have I'm already have 1 3, already have 1, so I'm left with 2 3's, so which means it's a squared. So I can then come, I know 3 squared it's 9, so I can write 9 here, then I can then multiply x times 3 and then get 3x, and then change the sign to positive 3x, and then plus, because if I'm saying 3 times 9, I will get 27, and then negative times negative, it will negative times positive, it will be negative. If you say now this 3x will cancel out with this 3, this x minus 3 will cancel out this 3x minus 3 here, and I will have a limit which will be looking like, let me clear this space here, run out of space. I will have a limit which will be a limit as x approaches 3 of x squared plus 3x plus 9. So now I can do my direct substitution. How I can just come here and do the direct substitution in place of x. Let's put 3 plus 3 plus 9. So if you know 3 squared, it's 9 plus 3 times 3 is 9 plus 9. So 9 plus 9 plus 9 is 3 times 9, which is 27. So this is your answer for this limit. So I hope you enjoyed this video. If you did, please don't forget to subscribe and like and comment. On the next video, I will be doing a one side limits. So I hope you will watch it. And please don't forget to subscribe to my channel and like my channel. Thanks for watching the video. I'll see you on the next video.